Hello everyone. Today I am going to start combination of resistors, session number 2. In this session, I will I will explain all the questions from NCRT in text question as well as exercise question based on combination of resistors. Okay, so let us start with the first in text question, page number 216. So first question is judge the equivalent resistance when the following are connected in parallel. So first one is 1 ohm and 10 to the power 6 ohm. So all are connected in parallel. Okay, so let us start with the first bit. R1 is equals to 1 ohm, R2 is equals to 10 to the power 6 ohm. So connected in parallel means 1 upon Rp is equals to 1 upon R1 plus 1 upon R2. Okay, so this is equals to 1 upon 1 plus 1 upon 10 to the power 6. Now 10 to the power 6 is 10 lakhs. So we'll take LCM after writing in that form. Okay, if you take LCM, we'll get 10 to the power 6 plus 1 upon 10 to the power 6, and this is equals to this one. Okay, so ये actual में 10 lakhs है. So 10 lakh plus 1 will be 10 lakh, 1 upon 10 lakh. Now if we divide this is, we will get approximately equals to 0.9999 ohm. Okay, and take the reciprocal. If we take the reciprocal, we'll get Rp is approximately equals to 1 ohm. Okay, so यहाँ पे जो यूनिट है वो 1/ohm रहेगा. So this is the first answer. Now the second answer, 3 resistance 1, 10 to the power 3 and 10 to the power 6 are connected in parallel, and the equivalent resistance will be equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So we'll get 1 upon 1 plus 1 upon 10 to the power 3 plus 1 upon 10 to the power 6. So take LCM. The LCM will be 10 to the power 6. So here 10 to the power 6 will come, here 10 to the power 3 will come, here 1. Okay, 10 to the power 6 means 10 lakhs, and 10 to the power 3 means 1000 plus 1. So we'll get 10 lakh 1001 upon 10 lakh, and this is approximately equals to 0.999000001 ohm, right? Approximately Rp will be equals to 0.999000001 ohm. So we can write as approximately it is equals to 1 ohm. So what is our conclusion? That in both the cases we are getting approximately equals to 1 ohm equivalent resistance. Okay, so now we'll move toward the next question. Next question, an electric lamp of resistance 100 ohm and a toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much as current as all the three appliances, and what is the current through it? Now this is a very good question. So we'll draw first a diagram. So these three resistance are connected in parallel. So first we will find the equivalent resistance. Okay, so R1 resistance is the resistance of electric lamp, and R2 is the resistance of toaster, and R3 is the resistance of water filter. Okay, and the total resistance of all these three resistance will be will take it as Rp. So 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Now substitute all these values R1, R2, R3. So 1 upon 100 plus 1 upon 50 plus 1 upon 500. 100, 50, 500, LCM will be 500. So यहाँ पे 5 आ जाएगा, यहाँ पे 10 और यहाँ पे 1. So 5 plus 10 plus 1 upon 500. So 16 upon 500 ohm we are getting 1 upon Rp. Now we have to take reciprocal of this one. If we take reciprocal, we'll get 500 divided by 16, and that is equals to approximately, not approximately, exactly 31.25 ohm. So this is the equivalent resistance of, this should be the equivalent resistance of electric iron, that is 31.25. Okay, now calculation of current through electric iron. So V is equals to 220 volt is given. We got RP also, and we have to calculate I. So we are using Ohm's law. So we can use directly that formula, I is equals to V by R और R is equals to V by I. इन दोनों को इंटरचेंज कर लेंगे फिर बाद में. So 220 upon 31.25. So approximately we are getting 7.04 ampere. So thus the current flowing through electric iron is 7.04 ampere. Okay. So this is the question number 2 of that Intext question. Now question number 3, already we discussed that in the first session, that what is the advantage of parallel circuits. Okay. So I'm going to do start question number 4. How can three resistors of resistance 2 ohm, 3 ohm and 6 ohm be connected to give a total resistance of 4 ohm? Now this is very important question, that total resistance 4 ohm होना चाहिए. ठीक है. सो इसमें जो छोटा जो रेजिस्टेंस है, सबसे छोटा रेजिस्टेंस ये वाला है. अगर हम लोग तीनों रेजिस्टेंस को पैरेलल में कनेक्ट करते हैं, इफ वी कनेक्ट ऑल द थ्री रेजिस्टेंस इन पैरेलल, so I told that the last point, the equivalent resistance is less than the smallest resistance in the circuit if all are connected in parallel. So 1 ohm 2 ohm से कम हो जाएगा, तो ये तीनों resistance parallel में connect नहीं है. So that means, okay, the resultant resistance is 4 ohm. It is greater than the smallest resistor, which confirms that all resistors are not in parallel. अब तीनों रेजिस्टेंस सीरीज में भी नहीं है. Why? Because if we connect in series, then we'll get the sum of all the three resistance, that is 11 ohm. So that in conclude that कि वो रेजिस्टेंस में सीरीज में कनेक्ट नहीं है. Okay, so now the sum is greater than 2 ohm. Now listen carefully, the sum is greater than 4 ohm, 2 ohm. ये जो 4 ओम आ रहा है, जो वो 2 ओम से बड़ा है, राइट. 2 ओम से बड़ा है, तो इसका मतलब 2 ओम के साथ में हम लोग सीरीज में कनेक्ट कर सकते हैं. लिसन केयरफुली, 4 ओम जो इक्विवेलेंट रेजिस्टेंस है वो 2 ओम से बड़ा है. दैट मीन्स 2 ओम के साथ में हम लोग सीरीज में कनेक्ट कर सकते हैं. लेकिन बाकी दोनों को अगर हम लोग सीरीज में कनेक्ट किए तो वो फिर 11 ओम हो जाएगा. इसलिए ये दोनों को हम लोग क्या करेंगे, पैरेलल में कनेक्ट करेंगे, राइट. So the sum is greater than 2 ohms. It means 2 ohm is connected in series with parallel combination of 3 ohm and 6 ohm. So this is the arrangement. Now we'll check the, we'll verify the equivalent resistance mathematically. Okay. So when 3 ohm and 6 ohm are connected in parallel, so the equivalent resistance will be, I'm going to take Rp dash. Okay. So 1 upon Rp dash is equals to 1 upon 3 plus 1 upon 6. So LCM is 6, यहाँ पे 2 और यहाँ पर 1 आ जाएगा. So 3 by 6, 3 by 6 will be 1 by 2. So Rp dash will be 2 ohm, which is in the series with the other 2 ohm. Like that, if we are getting equivalent resistance, ये दोनों series में आ गया. So series में आ गया, तो that means we have to add the resistance. Okay, so total resistance will be equals to Rp dash plus 2 ohm, and Rp dash we got 2 ohm, so 2 plus 2 4 ohm. Okay, so like that we have to use that concept. The जो last में मैंने conclusion बताया था, last point जो था, that is very important for this one. Now let us have the second bit, 1 ohm. अभी 1 ओम में देखो, 1 ओम इसमें 2, 3, 6 में सबसे छोटा कौन सा है, 2 है. अगर हम लोग तीनों को पैरेलल में कनेक्ट करते हैं तो जो इक्विवेलेंट रेजिस्टेंस होगा वो 2 से भी कम होगा, एंड वो कम ही है, 1 ओम. सो दैट इंडिकेट्स दैट ऑल थ्री आर कनेक्टेड इन पैरेलल, राइट. So this is the arrangement. So now we are going to verify mathematically. So if all are in parallel, so 1 upon Rp is equals to 1 upon 2 plus 1 upon 3 plus 1 upon 6. Now the LCM is 6, यहाँ पे 3 आ जाएगा, 2, 1. So we are getting 6 by 6. That means Rp is equals to 1 ohm. So verified. Okay, so in this way you have to make the arrangement. Now let us move toward the question number 5. What is the highest, the lowest resistance that can be secured by combination of 4 coils of resistance? 4 ohm, 8 ohm, 12 ohm, 24. So highest resistance हम लोग को तब मिलेगा जब हम लोग सबको सीरीज में कनेक्ट करेंगे. That will be the highest resistance we are getting, and lowest resistance when we are getting when we all connect in parallel. Okay, so resistance is maximum when they are connected in series. So highest resistance सबको ऐड कर लो, that is 4 plus 8 plus 12 plus 24. So 20, 28, 48. Okay, and resistance is lowest when all are connected in parallel. So 1 upon Rp is equals to 1 upon 4 plus 1 upon 8 plus 1 upon 12 plus 1 upon 24. So LCM is 24. यहाँ पे 6, 3, 2, 1 आ जाएगा. So 12 upon 24, that is 1 by 2. So the resultant resistance will be equals to 2 ohm. Okay, so now we are moving towards the exercise questions. Only one in-text questions was there based on combination of resistance. So page number 221, first question is based on equivalent resistance. A piece of wire of resistance is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio R upon R dash what? So हम लोग वायर को 5 equal parts में divide कर रहे हैं, तो each part will be has resistance R by 5. So that is very important. The total resistance R dash will be equals to, each part will be R by 5, and the total resistance when they are connected in parallel will be equals to 1 upon R dash is equals to 1 upon R by 5, 1 upon R by 5, total 5 times we have to write. Okay, so ये जो रेसिप्रोकल में जो हम लोग जो R by 5 हम लोग जो डिनोमिनेटर में लिखे हैं, so ये जो 5 है ये ऊपर आ जाएगा, इसका रेसिप्रोकल R by 5 का रेसिप्रोकल लिखेंगे सब में. So that means 5 by R we have to write 5 by R. So 5 by R 5 times will be equals to 25 by R. Okay, 25 by R. So that means अगर R को हम लोग इधर शिफ्ट करेंगे इधर, so R by R dash is equals to 25 मिलेगा. So 25 is the answer. So which option is correct? D. Hence answer D is correct. So this is the first question based on that series and parallel combination. Now the question number 5. How is a voltmeter connected in the circuit to measure the potential difference between 2 points? Okay, so parallel combination हम लोग देखे थे, जितने भी components रहते हैं उनमें जो voltage रहता है वो same रहता है. ठीक है, so voltmeter भी हम लोग क्या करेंगे, will connect in parallel to the component across which the potential difference we have to measure. Okay, so this is the diagram. Suppose one component is there, so we will connect it in parallel to measure the voltage. Okay, so now we'll move towards question number 9, which is based on combination of resistance. A battery of 9 volt is connected in series with resistance of 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and 12 ohm respectively, connected in series. How much current would flow through the 12 ohm resistance? Okay, so first of all we'll find the total resistance, क्योंकि सभी सीरीज में कनेक्ट है तो सबको ऐड करना है. So the total resistance will be equals to 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. So if we add all this, we are getting 1.4, so 13.4 ohm. So according to Ohm's law, I is equals to V by R. Okay, we can use any form. I is equals to V by R. So 9 by voltage is 9. Okay, 9 volt upon the total resistance 13.4. So 9 upon 13.4 is approximately equals to 0.6716 ampere. Now we have to find the current flowing through 12 ohm resistance, and we know that when all the resistance are connected in series, the same current will flow through each resistance or every resistance. Okay, when, so we'll write that concept first. When in series, the current passing through each resistor is equal to the current in the circuit. So current through 12 ohm is also equals to 0.6716 ampere. Okay, so now we are moving towards the 10th question. How many 176 ohm resistors in parallel are required to carry 5 ampere on a 220 volt line? So कितने सारे resistance, suppose हम लोग ले लेते हैं n resistance. Suppose n resistance are connected in parallel and the resistance R. ठीक है, so let R resistance n R resistance are connected in parallel and the total resistance, equivalent resistance is Rp. So how will you write the formula? 1 upon Rp is equals to 1 upon R plus 1 upon R plus 1 upon R up to n times. तो ये हो जाएगा n into 1 upon R और n by R, क्योंकि पूरा डिनोमिनेटर सेम है, तो 1 plus 1 plus up to n, so it will be n by R. Right, so Rp कितना होगा? What will be Rp? R by n, capital R by n, and Rp from this we can calculate. From this we can calculate V by I, that is 220 by 5. So we are getting 44 ohms equivalent resistance. So 44 ohms को हम लोग डिवाइड करना है कि कौन सा रेजिस्टेंस है? 176. हम लोग को इक्विवेलेंट रेजिस्टेंस 44 चाहिए. सो वी विल सब्स्टिट्यूट हियर 44 and will substitute here 176. Clear? So n will be equals to 176 upon 44. So 176 upon 44 means n is equals to 4. So 4 resistance each of 176 ohm connected in parallel will result in net resistance of 44 ohm, causing a current of 5 ampere to flow when connected to 220 volt. This conclusion is not mandatory. You can write directly. The number of resistance is 4. Okay, so now we are moving towards question number 11. Show how you would connect 3 resistors, each of resistance 6 ohm, so that the combination has a resistance of 9 ohm. Right? So 3 resistance 6, एक मिनट, इसको भी उसी कंसेप्ट से हम लोग करेंगे. 6 6 6. See, 9 ohm is greater than each resistance. Greater than each resistance. That means तीनों पैरेलल में नहीं है. अगर हम लोग तीनों को पैरेलल में कनेक्ट करेंगे तो वो 6 से छोटा मिलेगा. Right? So it indicates that all 3 are not connected in parallel. But all 3 are not connected in series also. क्योंकि तीनों को सीरीज में ऐड करेंगे तो 18 मिल रहा है. 6 plus 6 plus 6. So that means पैरेलल में भी नहीं है तीनों और सीरीज में भी नहीं है. नाउ इट इज, बट 9 इज ग्रेटर देन 1 रेजिस्टेंस, दैट इज 6. सो 6 के साथ हम लोग सीरीज में पैरेलल कनेक्ट करेंगे. सो दैट मीन्स वी आर गोइंग टू टेक 1 resistance, 2 resistance in parallel and 1 resistance in series. Okay, right. So we are this is the combination R1 R2 हम लोग पैरेलल में कनेक्ट करेंगे. ठीक है, और एक हम लोग सीरीज में कनेक्ट करेंगे. ओके, सो द रेजिस्टेंस ऑफ, फर्स्ट वी विल फाइंड दैट इक्विवेलेंट रेजिस्टेंस ऑफ दिस वन R1 R2. सो इक्विवेलेंट रेजिस्टेंस कितना होगा? 1 अपॉन Rp is equals to 1 upon R1 plus 1 upon R2. Right? R1 is 6, R2 is also 6. So we'll get 2 by 6. So Rp will be equals to 6 by 2. That is 3 ohm. Now the total resistance is, we got this is 3 and this is 6, and both are now connected in series. So 3 plus 6 will be equals to 9. Okay, so this is the first bit answer. Now we will move towards fourth B bit. Right. So B bit is 4 ohm. Now see 6, 6, 6. If we are connected all three resistance, 4 ohm यहाँ पर 4 ohm जो है तीनों से छोटा है, राइट, तीनों से छोटा है. लेकिन अगर हम लोग सेम रेजिस्टेंस अगर ऐड कर रहे हैं 6, 6, 6, सो वन एक फॉर्मूला है उसमें, इफ आर 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 इज कनेक्टेड, अभी जस्ट हम लोग किए थे जो पिछले क्वेश्चन में, दैट इज n बाई आर बाई एन आया था, आर बाई एन फॉर्मूला वाज देयर. ठीक है, इक्विवेलेंट रेजिस्टेंस पिछले क्वेश्चन में किए थे. So the same formula we can apply here also in order to decide. This is the rough work only. So R is 6 and N is 3. So 6 by 3 is 2. So अगर हम लोग 6, 6, 6 को पैरेलल में कनेक्ट कर रहे हैं तो 2 ओम आ रहा है. तो यहाँ पे थोड़ा कंफ्यूजन ये हो सकता है कि 4 ओम जो है वो सबसे छोटा है, 6 से छोटा है. तो अभी तक हम लोग यही कंसेप्ट पे थे कि अगर छोटा आ रहा है तो हम लोग पैरेलल में कनेक्ट करेंगे, लेकिन पैरेलल में अगर सेम रेजिस्टेंस को कनेक्ट कर रहे हैं तो 2 ओम आ रहा है, वी आर गेटिंग 2 ओम. सो दैट इज व्हाई all these three resistance we can't connect it in parallel. So what we will do, we will connect in parallel but two resistance will connect in series. So this will be the arrangement. ये दोनों रेजिस्टेंस को हम लोग सीरीज में कनेक्ट करेंगे और उसके साथ में ये वाला R3 पैरेलल में कनेक्ट करेंगे. Okay, so we'll find the equivalent resistance of this one first, that is R1 plus R2. So 6 plus 6 will be equals to 12 ohm. So this is the answer. Now the total resistance will be equals to, because this 12 and this 6 is connected in now parallel. Okay, so RS, ये RS हो गया, this is RS, RS and R3 are connected in parallel. So 1 upon R will be equals to 1 upon RS plus 1 upon R3. So 1 upon 12 plus 1 upon 6. So 12 और 6 का LCM हो जाएगा 12. So यहाँ पे 1 और यहाँ पे 2 आएगा. That means 1 plus 2 upon 12, 3 upon 12. So R will be 12 upon 3, that is equals to 4 ohm. Okay, so this is the final answer. Now we are moving towards question number 13. A hot plate of an electric oven. So this is the last question of that exercise based on combination of resistance. A hot plate of electric oven connected to 220 volt line has two resistance coil A and B, each of 24 ohm resistance, which may be used separately in series or in parallel. What are the currents in the three cases? ओके, सो फर्स्ट ऑफ ऑल अगर हम लोग सेपरेटली यूज कर रहे हैं दोनों को सेपरेटली, सबसे पहले दोनों को सेपरेटली, दोनों को सीरीज में और दोनों को पैरेलल. सो थ्री केसेस आर देयर. दोनों को सेपरेटली यूज कर रहे हैं, दोनों को सीरीज में यूज कर रहे हैं, दोनों को पैरेलल. सो फर्स्ट वी विल कनेक्ट इन सेपरेटली. सो रेजिस्टेंस इज गिवन 24 and volt is 220. So current I will be equals to V by R. Directly you can use that formula, V by R. I is equals to V by R. So don't use this one. So directly use this I is equals to V by R. So V is 220 and R is 24 ohm. So if we divide these two, we'll get 9.167 ampere. So thus the current obtained when the coils are connected separately is 9.167 ampere. Now we are going to connect both the resistance in series. Okay, so total resistance will be equals to R1 plus R2. If you are going to take R1 24 and R2 24. So R total resistance RS is equals to R1 plus R2. That is 24 plus 24, 48. Okay, so Now the current will be equals to, again my suggestion, use this formula directly. Okay, so we'll get 220 upon 48. So this is equals to 4.58 ampere. Okay, so thus the current obtained when the coils are connected in series is 4.58 ampere. Now the last one, when both are connected in parallel. So R1, R2, 1 upon R1 plus 1 upon R2, that will be equals to 1 upon RP. So 1 upon 24 plus 1 upon 24 will be equals to 2 by 24, and RP will be 24 by 2, that is 12 ohm. So again, according to Ohm's law, use this one, I is equals to V by R. So 220 upon 12 will give 18.33 ampere. So thus the current obtained when the coils are connected in parallel is 18.33 ampere. Okay, so this is the last question based on combination of resistance. Okay, so that's all for today's session. Thank you very much.